We start off with Charith Silva, a university academic at University of Salford and a data scientist working in electricity distribution network operate called Electricity Northwest Limited in Manchester, UK. He is in his final year of PhD studies, where his research interests focus on data science, geospatial big data, data mining, text mining, sentimental analysis, and machine learning. Charith will talk about a proposed framework for analysis and mining big data that will aid data science project lifecycle and bridge the gap with business needs and technical realities. Charith, the floor is yours.
Hi guys, my name is Charith Silva. I'm from Manchester, UK, but I'm originally from a small country called Sri Lanka in the Indian Ocean. I live in UK for the last 15 years. I'm an academic and data scientist as well. I'm going to talk about a new framework today. I wrote a research paper a few months ago, presented in Prague about this framework, but it's a different version of the framework. This framework, this outline. Anyway, the reason actually I thought to write a research paper about the framework, when I teach in this course called MSc in Data Science in the University of Salford, Manchester, UK, we teach people the modules, big data, data mining, machine learning, artificial intelligence, advanced databases, which is my subject. At the end, and we gave project to students as a dissertation, industry projects. Most of the academics actually always talking about theoretical aspect, but I'm coming from industry background, and I want to do kind of like contribute to the industry and the academic both, kind of bridging the gap. Always normally, students come and talk to me and ask, they call me Silva because they can't pronounce my first name. Silva is a kind of Portuguese name, and there are lots of footballers in Manchester called Silva, right? And they call me Silva. Where can I start the project? And it's of course, when you do the industry project, if you are a student or junior data scientist, you're completely lost. Where are you going to start? Are you going to start from the spatial data mining or machine learning or doing some analysis in the database? You're completely lost, right? If you have a kind of framework, very sophisticated framework, A to Z, very simplified version, it might help, right? I'll explain in a minute the proposed framework, but this is kind of my motivation to do a research and write a conference paper. It's all been published in a journal called ACM. It's a digital a journal. Right, I'm pretty sure you're all familiar with this graph, right? This is the data science. When I teach the students, I use mainly this graph. This is actually data science. So mathematics, combination of mathematics, combination of computers, and combination of domain experts. If you don't have any domain knowledge, if you think you can be a data scientist, I'm pretty sure it's not going to be successful, right? So I'm coming from electricity distribution background. I have an expert, I'm not expert, I have some knowledge in electricity distribution. This is my domain expert. Same time, I have some mathematics background, and same time, I have a computer background. If three combined together, the three skills, then you can be a data scientist, a good data scientist. You can be a data scientist if you learn a bit of R or Python, right? But if you want to be a good data scientist, if you want to be interpret your results, then this graph is very important. The data science, I'm not going to explain what the data science means. I'm not here to do the definition. For my understanding, data science is find interesting and previously unknown patterns from the data. Large amount of data or small amount of data doesn't matter. Normally, it's a large amount of data. Right, big data, again, the definition. Reason the big data is taking over the world. Actually, people don't know what actually big data is. I'm also not expert in the big data. People do different definitions, 3 Vs, 4 Vs, 5 Vs. This is actually 4V version. The volume, velocity, and variety and veracity. 9 out of 10, in my experience, in academic life and industry background, data science project, they are not big data driven data science project. Am I right or wrong? Most of the time data, they're not big data though, right? By profession, I'm a DBA back in the days. Even the students or industry, they're not ready for the big data platform. I'm not saying 100%, but most of the time, 9 out of 10, my experience in UK, the data, they're not big data, right? It doesn't matter, right? If the big data or small data doesn't matter, data science can apply in any data set. Even I have seen some people find good, interesting pattern with the 200 set of data rows in the database. It doesn't matter. As long as you use the right algorithm, you can find patterns as a data science. Right, it's a big data. Normally, these days, the data has become more unstructured. As a DBA, back in the days, we dealt with structured data. It's like a relational databases. Then it's become semi-structured and quasi-structured. Now it's unstructured. Now we are talking about, I was in a meeting in Salford with council. Council means local government bodies in UK. They have tons of papers, like papers. They don't know what to do with them. Right? What we propose, let's scan all the papers, we collect all the data, and put it through the text mining. And we can do some sentimental analysis or opinion mining. And we can find some interesting pattern, what people say about local bodies or opinion. There are lots of data in the paper format still in UK. I don't know how about in Serbia or Europe. There are lots of text in paper format. We can scan them, we can do the OCR, like a optical character reading, and convert them to text. Then we can mine the text. You can use some text mining algorithms, opinion mining, sentiment analysis, again, get some data. But that's called big data for me, right? If you have about 1,000 records or 100,000 records, they're not big data though. They're just a data set. Big data I'm pretty sure I don't want to explain them. Tomorrow, we have a whole track about big data. Right, anyway, that's how, my main motivation, the technical motivation, is to introduce this framework. It's a different dimension of this data science project. Normally data, it used to be like a relational data. Now it's become big data. And we call volume, velocity, and variety, and veracity quite a lot. I work in industry and academic, but there are lots of technologies. Can you keep up with the speed? I can't. There are lots of packages coming up, R, Python, TensorFlow, deep learning. There are lots of things, right? But you don't have to focus on everything. You have to be specialized. And again, with industry project, lots of project managers want to do magic with the data science. It's not possible though, is it? They want to find the patterns, we want for artificial intelligence, they want to do quite a lot. But when project managers, they put more pressure in the projects, then it's more complicated. As a data scientist, you're completely lost. Again, the new data sources, the remote sensing, IoT devices, they get lots of data, and the text, Twitter data or Facebook data, get new data sources. These are normally the data science project involved, but this adding more complexity to the project. The main motivation is in terms of data characteristics. Companies, they need real-time analysis and visualization. Real-time or near real-time, right? Sometimes it's impossible to have a real-time, but you can have near real-time. It's like a 1 or 2 seconds delay. And they do lots of magic with the data, right? That's fine, but if you join the company as a junior data scientist, if company project managers, they give you a task, obviously you can't say no. You have to do a bit of research, then you need to come up with some sort of solution, right? Now, the main objective of this research and the framework is to simplify the data science projects. A to Z, how to do it, break down. these frameworks might not useful for the senior data scientists because they've been in the industry and done everything. It might actually I focus mainly in students, mature students, and junior data scientists. Okay, and I'm proposing a new framework. It's not actually ultimate project. I mean, like a framework. You can add a few things. You can change some few things. You can customize it, right? It's the main methodology. I use quantitative and qualitative research. Talked to lots of people, talked to lots of industries, and did a lot of reading, research papers, and did lots of projects, small projects, not industry scale, small project with students. That's kind of methodology I used to bring the framework. The case study. I'm going to use this case study when I explain the project steps. I was in Vietnam 2 weeks ago for kind of like a workshop. I was invited to join over 20 university academics from UK and join with another 20 academics from Vietnam side to help Vietnam economy in the south region of Vietnam in agriculture, right? Reason actually I won't use this case study, not because I was in Vietnam. We talk about autonomous cars, robotics, quite a lot high-end technology, but still, we can use data science to help the grassroots level kind of industries like rice farming, right? And crop detection of crop diseases. I'm going to use this case study. In Vietnam, there was a problem in Vietnam. It's climate change, then seawater level is rising, and seawater level is mixing with the land the water. Then actually the saltiness of the water, called salinization, is increasing and impact the farmers. Then what we proposed, and we proposed to use existing data from satellites and try to use some IoT devices to implement, actually deploy IoT devices in the field and get some data and build a big data platform and do the prediction modeling and actually predict the saltiness, water saltiness for short term and long term. Then farmers can get this data from environmental agencies, then they can manage their crop production, right? This is actually come up with at the end. We came the cyber physical systems for controlling river water quality in Mekong Delta, Vietnam, and the joint kind of operation in the University of Canto, University of Salford, which is me, and Sussex, Wolverhampton, and that's another university in Vietnam. The reason I won't mention this one, Vietnam is a kind of like a third world country. It is a third world country anyway, purely based on agriculture. But they won't do something with the data science and artificial intelligence to help the economy. We're not talking about robotics here. We're not talking about autonomous cars. They're far away from autonomous cars, right? And they're talking about helping the economy. Right? Related works. In research, it's obviously we need to mention the people who've done this before, because I'm not the main person who actually proposed this framework. There are some frameworks, if you want to use, when you do a data science project, this is one of the good ones. It's called David Bichette and Data Analysis Lifecycle. It's one of the good lifecycle, data science lifecycle. There's another one called Vania. There's two I normally use. And there's another one called Crisp DM. Have you ever used Crisp DM for any projects? Yes, in UK we use, most of the time, data science project, we use the framework called Crisp DM, CRIP, Crisp DM 2.0. That's the process, right? I'm proposing this one after my research, and I'm proposing this framework for the data science project. Very simplified version. I'll explain in one by one. First of all, problem definition. When you have a project, you have to define your problem first. If you don't have a problem, you can't find a solution, right? Doesn't matter, data science or in data analytics or business intelligence, you have to define the problem very granular level, right? Then at the end, after you build the model, then you can re-evaluate, have you achieved, have you found the solution for your problem, right? This is very important, find the problem. Document and find and document the problem. For example, in the case study, I use Vietnam is actually struggling with climate change. Climate change is not a problem. Climate change, we can't solve climate change, right? But salt water mixing with river water is a problem. That's the granular level problem, right? Clearly define and write down in your piece of like a project plan. Then you go for a requirement gathering. Second one, requirement gathering. I always tell my students, please don't be too smart, right? When you do the project, please talk to your experts, and called domain experts, right? If you want to do something with agriculture, please talk to farmers or people who know agriculture. You don't try to gather all the requirements by yourself. It's not going to work. Sorry, it's my experience, right? You might have a different experience. And always talk to people who actually doing the project. For example, the robotics, please talk to electronic engineers, right? And if you do autonomous cars, please talk to people who in the automobile industry, but don't try to do yourself everything, right? That's the requirement gathering. Then data acquisition. When you acquire data, please don't rely on the one data source. There are lots of open data sources. Back in UK, we have lots of, that's a drive, open all the data source in the company. There's a limitation with the GDPR, right? But acquire lots of data and put them in a system. Please don't stick with the one data source. Then you go to data fusion. Data fusion is combine data sets and get more insight in the data and do the filtering and pre-processing. Sometimes, for example, in terms of my case study, we are focusing on how to improve the water quality not in Vietnam. It's called Mekong Delta. Mekong Delta is like a south part of Vietnam. Vietnam is a long stretch of country. It's land. We are focusing on the data in the southern part of Vietnam. The geography is so important. Then when you do the filtering, filter data only relevant to that geography, right? Then data extract and store. After you pre-filter, you extract the data and store in your computer system, either cloud or the local computer or somewhere else in third-party data center. But in those two, you can interchangeable. Some people want to store all the data in your system, then do the pre-filtering and pre-processing. It doesn't matter, right? As long as you do one of them, doesn't matter the sequence. Then you do the data cleansing. Believe me or not, you almost all the time, most of the time in your project, you cleanse the data and quality assurance, right? You have to remove all the null values. If there's any missing values, there are some algorithms. You can use algorithms, I don't know, I can't remember on top of my head. Repopulate all the missing values. You take lots of time. Then you big data processing. I'm not a expert in big data processing, but there's a good research article I refer called done by I think Dr. Atta, and he actually proposed 8 pre-processing requirements for data processing, streaming processing, right? If you read this research paper, you can understand the big data processing, stream processing, how important. But as I said earlier, 9 out of 10 data science projects, they're not big data, right? They are just data, right? Are you agree with me or not? Yeah? I learn in hard way, not in theoretically. Then, either, if there's no big data, you don't have to think about big data processing. Just disregard that step. Then go to feature selection. Feature selection is important. For example, if you have a data set with 100 columns, then what should you do? Then do you want to use 100 columns to create a decision tree? Right? It might take about 2 days to process in R. You have to select the obvious columns we call attribute selection or variable selection or feature selection, right? There are some algorithms or packages called Baruta in C, R. Yeah, there are lots of things. But you can do the feature selection. It's very, very important. And then the data partitioner. If you're a data scientist, you know you need to partition the data in the training set and the test set, right? It's so important. If you use test set and the test set and the training set 50-50, you're 50% wrong and 50% right, right? Either way, normally I use 80 to 20%, right? 80 to build the model, 20 is to validate the model. What you can do, 80, 10, 10, right? It's a trick I use. 80 to build the model, 10 to test the model, again, another 10, test the model, right? Then you can test 2 times, right? Then you go to the last part. That's the data. This is the data science. Before that, this is not the data science. This is actually data engineering. Now it's come to data science. Then use all your magic, data mining, machine learning, artificial intelligence, whatever, the statistics. Do all this analysis. Then you get your results. Then do the prediction modeling. For example, if you're a data scientist, you know what's independent variable and a dependent variable. You chain the independent variables, check what happened to the independent variable. Data science, I don't think even Albert Einstein can give a problem, data science problem, if he lives. Anyway, he died. He can find algorithm, the suitable algorithm like that. Data science is take time to find different algorithms. Simple linear regression, multiple linear regression, logistic regression, decision trees, random forest, you name it. There are quite a lot, right? Can you remember all these algorithms? I can't, right? When I just go to online references, I just use the algorithm. Yeah, and after the prediction modeling, then do the results aggregation. For example, normally, I use data mining and machine learning separate study, then aggregate the results to get more insight. Sometimes might not work, sometimes might work, right? Then do the data visualization. But normally what we do, if we don't have the follow framework, you just straight away you do the data visualization. But when I present this to my students a few months ago, one of the students told me, why you putting data visualization here? This is a result visualization. That's true, right? What you can do, we can do data visualization on the top, right? Then you can see the results, data, the distribution of the data first, then you get more insight before you do analysis, right? That's correct, actually. I learn a lot, right? He said, yeah, the data visualization can come here, somewhere here, see all the raw data, then actually this is the results visualization. But I left it like that because I want to tell you the story, right? Actually, data visualization should be the results visualization. Right? Then do the evaluation. When you do the evaluation, you always go back to the beginning. You do the evaluation, make sure you align with the problem and the requirement, right? If evaluation is completely different from your problem and requirement, you fail. You completely fail, right? So, for example, normally data science is very, very energetic, enthusiastic, right? You try to solve one problem and you actually found a solution for another problem at the end. But if you have A to Z end-to-end solution, end-to-end project lifecycle, then please stick to the like a solution with the problem. Make a line. Maybe if you find something interesting, then we can have another project, and we can create another project and start again. Right? Conclusion is just a simple framework I introduced to simplify the process, to help students and junior data scientists start A to Z And again, this might help to project managers. For example, the project managers in UK, sorry, I should not say this, but anyway, there are lots of project managers, but very few technicians, right? For do one project, maybe 1 or 2 data scientists, maybe about 10 project managers, right? They manage the project, there's only 2 people to do the job, right? But anyway, I don't know about here. That's how it works. I was going to say, yeah, project managers, it might help to do forecasting for how long it take. Yeah, how long it take to do the project. For example, you can break down the small project in small pieces. You can actually get, you can allocate how many man hours for each like a sector, and how much going to cost. For example, per hour. If you still about 10 man hours for data partitioning, yeah, just do the costing. It might help to do costing for project managers. The future work, this is actually not ultimately like a static framework. You can add, you can change, you can write another research paper, I don't mind. But this is a basic framework. And we can do the simulation to make sure this project framework works. Thank you very much. Again, if you need any like academic kind of collaboration or anything, just send an email to me or my supervisor. I'm a PhD student still. And my professor, Dr. Mosarai. Yeah, then we are happy to work with you guys.
Thank you,
Thank
Charith.
you.
Thank you.